Hi, this is Mrs. Basin, and today we're going to talk about atomic and molecular weights, which is section 3.3. So when we're looking at the atomic mass scale, we use things called the atomic mass units, or AMUs. These are units that we use when we're dealing with things that are very, very small. So when we're talking about the masses of atoms, these are very small amounts. So in order to make it a number that we can deal with, we've come up with this atomic mass unit. So if you notice there, one atomic mass unit is 1.66 times 10 to the negative 24th grams. So that's a very, very small number of grams. So instead of trying to deal with these very small gram numbers, we're able to use this 1 AMU. So 1 gram is equal to 6.02 times 10 to the 23rd AMU. And then carbon 12, by definition, is exactly 12 AMU. So all of the masses are based on that carbon. When we're talking about molecular weights, on the periodic table, we know that most of those numbers there are decimals because that is the average atomic mass of all the isotopes of a given element. Now, there are some that we talked about that have parentheses around them on the periodic table. Those are radioactive. Those are unstable elements, so they don't have an average atomic mass. But when you have an atom that has more than one isotope, those different isotopes are averaged. Now, it's not just a regular average, like you would average your grades where everything is equally. It would be something where you have different categories that are weighted with different weights. So what you're going to do when you do an average atomic mass, it is a weighted average based on abundance. So to come up with those particular numbers, a sample of an element is run through a mass spectrophotometer, and then you get a readout that tells you what percent of each isotope is actually present in the sample. So all of these numbers that we use when we actually calculate average atomic mass come from data from that mass spec. So there's a lot of words that can be used interchangeably here. So you can see there it says atomic weight is also known as average atomic mass, so those two things can be used interchangeably. And the formula that we use to calculate that is given right here. So you take the mass of the first isotope times the abundance, mass of the second times the abundance, mass of the third times the abundance, etc. Now you have to make sure that when you use that abundance, you either use it as a percent or you change that number to a decimal so that you end up with the correct values there. So let's look at an example of this. So it says we have naturally occurring chlorine, and the values are 75.53% Cl35 that has a mass of 34.969 AMU, and then the other 24.47% Cl37 that has a mass of this. And again, those masses and those percentages come from that data from that mass spec. So what we need to do here is calculate the average atomic mass. So to do that, our average mass is going to be mass times abundance of each isotope, and then we're going to add them together. So mass of our first one is 34.969, and then our abundance is 75.53%. Now you could use that as long as you use it as a percent and you take 75.53% of that mass, you could do that. I like to just change them all to decimals, so I'm going to make this 0.7553. So that's my first isotope, plus the mass times abundance of the second isotope. So the second one has a mass of 36.966, and it has an abundance of 0.2447, or 24.47%. Okay, so then I'm going to go ahead and do the calculation there, and I should end up with 35.46 AMUs. So when we're talking about average atomic mass, those units are actually atomic mass units, or AMUs. Okay, the next thing we want to look at is a formula weight and molecular weight. Again, these are two terms that can kind of be used interchangeably. Formula weight just means what is the sum of the atomic weights for everything in the chemical formula. So basically the mass of the compound. So in this case we have CaCl2. If I want to know the formula weight, which just means what is the mass of that particular compound, I would take my 1 calcium, 2 chlorines, and then get my total. Now these numbers here, that 40.08, 35.43, those come from the periodic table. So those are the average atomic masses of the individual elements, and then you just add them up. Now the difference in the terminology here, a formula weight versus a molecular weight, it's calculated the same, but notice here it says formula weights are generally reported for ionic compounds. So you'll most of the time hear that term formula weight when you're talking about an ionic compound. Now when you're talking about a covalent compound or a molecule, you'll hear the term molecular weight. Again, if you notice, it's the same deal. All you're doing is adding up the masses of all of the substances in that particular formula. So again, molecular weight, formula weight can be used interchangeably. Formula weight usually used more with ionic compounds, molecular weight terminology usually used more with molecules or covalent. Okay, so let's do a practice of one of these. And again, this is something we've done before, so this shouldn't be too new. You could do this two ways. You could just plug this all into your calculator and add it up. If you want a little more systematic way to do it, we would list all the substances, how many of each, and then multiply by the mass, or the average atomic mass. So carbon is 12.01. Again, that number comes from the periodic table. Hydrogen, mass 1.01, oxygen, mass of 16. So then I add all those up, and I would end up with 342.34. Okay, for the second one, I'm not going to list it all out there. Actually, I'm going to list the first part just to kind of address this parentheses issue. So I have calcium, nitrogen, and oxygen. Calcium I have 1. Nitrogen, remember if there's a parentheses and a number outside, that gets distributed to everything on the inside. So there's 2 nitrogen and 3 times 2 and 6 oxygen. So again, you multiply each of those by their molar mass, or their mass, average atomic mass of the periodic table. And when we add all those together, we get 164.10. And again, we could list this in AMUs. I forgot my unit on this one. So AMUs would be my unit for that. Okay, another thing we can do is we can look at the percent composition of a substance. So when you do percent composition, what you're looking at is what percent of the mass of that compound comes from those individual elements. So one formula that you can use, and I'm going to show you the way that we did it in Honors Chem to kind of tie that back, but if you don't want to do it that way, you could use this formula here. So to get the percent of the element, you would take the number of atoms, so how many atoms are in the compound, times the atomic weight from the periodic table, divided by the formula weight of the compound, which is the total mass of the compound, times 100. That'll give you your percent composition. So I'm going to work through this one like we did before, but again, you could do it either way. So to do percent composition for C12H22O11, that was that compound that we just looked at the mass for on the other example. So I have 12, 22, and 11. So I'm going to start this out the same way, where I am going to figure out what is the mass of each element, or how is that contributing to the mass as a whole. So carbon, this contributes 144.12 AMUs. This is 22.22, and then this one is 176. Okay, so then after I do that, I'm going to divide by the total. So if you remember from that previous example, my total here was 342.34 AMUs. So I'm going to take each one of these and divide by 342.34 and then times 100. So 342.34 times 100 to get my percent. 342.34 times 100, and that'll give me my final percent here. So once I work through that, I will find that carbon is 42.10%, hydrogen 6.49%, and oxygen 51.41%. So all of these percents should add back up to 100, or really, really, really close to 100. But again, you're taking the mass of each component and you're dividing it by the total, multiplying by 100, and that gives you your final percents.